Hello, good morning, good afternoon, good evening, everyone. Thanks for tuning in to this session titled Networking and Security for All Workloads with NSX Data Center. My name is Jonathan Morin. I'm a product line marketing manager here at VMware within the Networking and Security group. Just a quick background on me. I've been in the networking industry for about 15 years so far. Started back designing MPLS networks in the early 2000s. For some test labs and consultants, and joined VMware about 2 years ago. So let's get started. Before we start to get into the product, I think it's important to understand the context in which NSX came about, and I think a phenomenon that's going on just across our entire world and in our lives in so many different ways, which is, I think, best summed up by Mark Andreessen's quote, and how he encapsulates the investment philosophy actually at Andreessen Horowitz. This is a company that invests in all sorts of industries across the board, and it's that, in short, software is eating the world. What he means by that is this, what some call digital transformation, what others call offline to online transformation of business. Basically the fact that with software, with the ubiquitous access of internet, and not only hardwired but mobile these days, wherever we go, everywhere we go, measuring data, capturing so much of our lives, industries across the board are just being transformed. So, classic example being how if you think back to your last VHS or even DVD rented at Blockbuster, you probably didn't imagine that you'd be watching all of your video streaming online with companies like Netflix and Hulu, all powered by software, but not just for software's sake, but because they realized there's a better model to deliver video streaming. And similarly, VMware found, starting with Nicira back in the day, which we'll get into, that networking too could be done simply better with a model that started in software first. So now let's double click into our data centers today, and we'll get into a bit of a cloud from there. In some ways, we can consider we can think about our data center architectures with three architectural components that, of course, work together. But from an infrastructure standpoint, we basically have our compute, basically our servers and our hosts, our storage, where the data sits, which has its own architecture, and then the networking, which too has its own architecture to not only connect compute and also with storage, but to connect also with the internet and provide services like load balancing and security services like firewalling to decide what should go where and when, and also when not. So each of these components have been there for some time, even longer, you could argue, than the internet. We always had compute. There was always computing, of course, with computers. Data had to be stored somewhere, and somehow these all had to be interconnected with the networking. And in the past 20 years or so, actually even longer, to some extent, if we think about the early days of vSphere, these components have been, also, as we discussed earlier, transformed by software, thinking about virtualization, which is really that software-first approach, whatever word you use for it. But networking has, comparatively to compute and storage and what we see in the cloud, stalled to some extent. At least that was kind of the point of view when software-defined networking came about, which led into network virtualization. So what we're going to talk about today is addressing exactly that. How can we use software to enable networking, to keep up with the pace of business, to provide better security and better application-based services to what's running in the data center, and of course to do this efficiently and which enables us to control costs. And finally, we talk about data center components just now, but our compute world, our infrastructure world, our IT landscape is much broader than just the data center, isn't it? We use a lot of public clouds now. Actually, in many cases, different teams within our organization use different public clouds. So if I say public cloud to one group within your organization, they may immediately think of the app they started in AWS. If I say public cloud to another group within your organization, they may immediately be thinking of an Azure migration or VMware Cloud on AWS, the VMware offering, or maybe VMware partner clouds like through IBM and other VMware partners. Point is, it's not just one public cloud that we use anymore. It's actually multiple public clouds. We live in a multi-cloud world. In fact, the State of the Cloud report that came out this year, an independent report, not from VMware, but from RightScale, found that on average, not on the high end, not on the low end, but on average, organizations, enterprise organizations use 5 different public cloud services, 5 on average, which means that the high-end tail is much more than that and the low-end tail is lower than that, but even in those cases, sure, in some cases only zero, but even on the low end, still using multiple clouds. So with that in mind, let's take a picture of what our infrastructure landscape really is starting to look like. It's more than just the data center, and it's more than just one cloud. It's this landscape of clouds. And increasingly, if we think about the future of IoT and the evolution of how the edge is connecting, the amount of data that the edge is generating, and applications that are based around the edge, not to mention how our edge branch offices are being connected through technologies like SD-WAN, across the board, networking is being done increasingly via software. It needs to be intrinsically secure, and it needs to span this scope, this wide, this more increasingly diverse landscape of IT that we're dealing with. So this is really how VMware is thinking about networking, and it's important to kind of lay this foundation, because it sets the tone for why NSX is existing and why we've made some of the architectural product decisions we've made with NSX. And this is really what we call the virtual cloud network, which is not a product from us. It's really how VMware sees networking evolving in the years to come. And we've actually already done some work to start down this journey. And if we think about it just a bit more tangibly, it's taking a step back and thinking about, what does our network look like today? Where are our applications, our users? Where are our data? Where's our data? And how should a network of today and tomorrow look to connect and protect these apps, these data, these users across the board, pervasively, wherever they may go, scale, grow, and live. So whether that's public clouds, VM-based applications, containers and microservices-based applications increasingly, running in private data centers, whether our applications are being delivered by virtual desktop infrastructure-based environments, increasingly with IoT edge, and also being used by the more core networks, by the telcos and service providers. And what does that look like? How is that transforming? And how can we have an approach that spans across all of these? And that's what VMware calls the virtual cloud network, which starts with technologies like NSX. And actually, with this vision of the virtual cloud network, NSX has expanded beyond just a single product to a portfolio of products. And before we dive into the last thing I want to share before I get into how NSX works is just to explain that NSX to us is now this kind of broader landscape, that addresses the virtual cloud network, and is this broader span of products. And we are going to focus on NSX Data Center today, which is really what we used to just know as NSX. So if you're not familiar with this new branding, if you think of NSX, that's now called NSX Data Center, and actually also NSX Cloud, which is the same NSX as we used to know applied to cloud workloads, where NSX Data Center is the NSX we used to know applied to data center workloads, as opposed to NSX SD-WAN by VeloCloud, which is the SD-WAN part of our offering, which is really critical to that end-to-end virtual cloud network vision that we talked about, as well as NSX Hybrid Connect, which aids us in that bulk migration of workloads between private the data centers actually alone, as well as between private data centers and public clouds. That's where NSX Hybrid Connect really comes in. And then finally, the pure security play within this portfolio, which is app defense. How do you take an app-centric approach to security, not only from a network side, which we will definitely talk about today, but actually just from an application process standpoint, where we're locking down application good behavior as opposed to chasing bad behavior. And of course, all of this being managed by VMware's own visibility and operations tools, Network Insight and vRealize Automation, as well as a whole host, an ecosystem of third-party tools, which we'll get into at the end. Okay, so that kind of lays the foundation for what is NSX from a portfolio perspective, and just so we're using the same lingo and product names, how it fits into the broader vision of the virtual cloud network. So now let's dive into NSX Data Center specifically. What is it? How does it work? And how does it deliver on this promise of network virtualization? So let's go back to that image we had that really encapsulated this notion of moving from data centers to centers of data, which of course still includes the data center. And that is where the foundation of NSX technology resides here. So it all starts with the physical infrastructure you already have. Just as with vSphere and the VMware hypervisor, ESXi, starts with the compute infrastructure you already had and turned a single server into 10 servers, which is what server virtualization did. Network virtualization too starts with the existing network infrastructure you have, the existing compute infrastructure that you already have. And actually, that's exactly where the NSX platform runs. And architecturally, it was that ideal layer where you can start to virtualize the network. It's starting in the hypervisor. So that's where a lot of the components that we're going to be talking about are actually running, not as VMs, but as intelligence that gets embedded into the hypervisor. So a lot of us are actually using network virtualization in some way today already. Even if you're not using NSX, you may be using vSphere with a virtual switch. It could be the virtual standard switch. It could be the virtual distributed switch, the VDS from vSphere. This already takes a concept that's been familiar in networks for many, many, many years, the switch, and implements it in software, distributes it across virtual switch, your compute hosts, and it enables this any Mac to any Mac communication, potentially, this distributed virtual switch. And what NSX does is it starts with that seed concept and blows this out across the networking functions of your data center. So virtual distributed router, as well as switch, virtual distributed firewall, and as well as a load balancer. So these are kind of the four core functions that are baked into NSX. We also integrate with a bunch of third-party platforms if you prefer to use one of those. And whether you're using the baked-in NSX router, switch, firewall, or load balancer, it's also providing the software-based layer within which to insert services like this down to where your applications are, as opposed to separate from your applications with a physical appliance, or even with a virtualized appliance with a VM, although we do integrate with those. So it starts with just this idea of let's get these functions as close as we can to the application. And there's a variety of ways to do that, especially with the ecosystem. But let's start with giving these core functions directly in the NSX platform: routing, switching, firewalling, load balancing, all running in the hypervisor, not in a VM. What this allows us to do now is apply the same operational model that we've had with a virtual machine to these network functions. So each VM essentially in implementation, getting its own firewall, its own load balancer, etc. Now, of course, these are distributed functions and centrally managed functions. So it's not a matter of having to manage a firewall or load balancer for every single VM and having to click an extra time for every single VM, but doing this in a central place, a central interface, the NSX interface. We'll talk about how you can use both the GUI automate as well as, or to do manual steps, as well as APIs or third-party tools. But using that central place to administrate all of these. For some time with VMs, but of course, the landscape of technology never slows down. So what we found is, of course, applications are changing. What we used to know as a 3-tier simple app, and maybe web application, presentation tier, and database tier, that is now evolving into a much more distributed, much more complex architecture with what we call microservices architectures in this world of cloud native and often using containers. Why is this happening? Is it because the container is better than a VM? Maybe, but more importantly, it's happening because the app developers themselves, and for those of you joining on that side, are understanding that applications are more resilient, are more conducive to continuous improvement if they're built in smaller chunks. And those smaller chunks can be addressed while the rest of the app stays live if you do distribute your application intelligence and code into these smaller chunks, these microservices. And that's really why containers are coming about. The problem is, from an IT perspective, what we're often doing is we're provisioning a VM, or maybe we're provisioning a bare metal server for containers, or maybe it's a public cloud. Whatever we're provisioning for developers to use, those containers are kind of running in a black box. What is going on between those containers? How do the microservices work? How can I help manage a pipeline or help debug an app if it's just this black box? So we'll get into this in more detail, but just to continue this thread here, what we have going of the fundamental elements of how NSX works, what we're now doing is plugging directly into the container interface, which is a standardized interface, the CNI, Container Network Interface, and starting to not only apply a lot of the things we've been talking about, catered network services, firewalling, load balancing to the container, but also even just from day one, before even applying any of those, starting to gain visibility across teams for what is going on in these microservices. What does the flow even look like between API calls, and how can I help in a debug situation, or as apps go from test to production, or as I try to help with security in this new world of cloud native apps. So that's increasingly where NSX technology is being applied, which is really exciting and kind of changing the conversation between IT and developers. And then finally, as we talked about before, our organizations are using a whole host of public clouds. And just to break this down even further a little bit, especially for those who are maybe familiar with VMware-based clouds, the point is, in some cases, we get VMware technology in the cloud. That's the case with VMware Cloud on AWS offering. So these are these green clouds as I've colored here. This is also the case for VMware partner clouds, such as IBM. But that's not always the case, right? Some clouds, of course, AWS, the biggest cloud in the market, doesn't run on VMware by default. By default, developers are swiping their credit card, getting a VM, an AWS VM, and starting an application. This is also happening increasingly in Azure and other public cloud services, native public cloud services, these native public clouds, which I've painted blue. So, of course, I think we're, as maybe folks may be more familiar with offerings like VMware Cloud on AWS and with our VMware partners, NSX technology is already running in these clouds. What may be less familiar is that with NSX Cloud, customers are now also able to extend their NSX Data Center environment to address networking and security challenges in native public clouds like AWS and Azure using what we call NSX Cloud, which is basically just that. It's that taking that NSX Data Center installation you have, adding in an AWS VM, and that's what we call NSX Cloud. So this is kind of just the broad landscape of how NSX Data Center works, how it's bringing network services closer to VMs, and with all these things running in the hypervisor kernel, how these are being extended into container platforms, which we'll get more into, and how it's also being extended to public clouds. The NSX architecture, which we won't get into as much today, given that this is more of an introductory session, of course, does have some VMs running both for management appliance, NSX Manager. So that is a separate VM. It's not running necessarily in the hypervisor, so that you can operationally move where that is going to run. That is how humans interface with NSX through the NSX Manager. There are also VMs in the architecture that run the NSX controllers, which is how networking connectivity between all these endpoints is managed. But how, for example, the firewall is running and the load balancing services are running, this is all directly in the hypervisor. This also allows NSX to scale with high performance by running in the kernel. So basically, as you add hosts, you're also adding networking capacity and performance. So what have we seen with this? We talk a lot about, this industry. You look at analysts, they talk a lot about silos within IT that need to be broken down. We believe that no single tool can do this. This is a complex human artifact of how we organize teams, but it is still organized around how technology has been defined. So as we do bring things more into software and enable these broader platforms, we may not get this beautiful harmonious picture on the bottom that we see here overnight. But I think, as we talk to all of our customers, we still see people moving in this direction of, yeah, we didn't used to talk to that team, but now we're opening up this interface. Or maybe in the most extreme cases, yes, we have an SRE that manages like our pipeline. So applications are being taken out of production and back into production multiple times per day for edits. Of course, we're not all there yet, and it may not even make sense in some cases, that specific example. But the point I want to make here is a lot of where we spend our time is not only just on the product and the architecture, but starting, before we make architectural decisions, starting from a human design approach. How should these teams, what are our customers looking for and how their teams want to work differently, want to interface differently, want to collaborate differently, and then architecting products around that. So with that, we talked about NSX technology fundamentals. Note here about how this is starting to change how teams organize themselves, which, by the way, I think is just an absolute huge opportunity for career growth and development. And this is something we call the NSX mindset. This fact that as this shift happens, it actually creates a variety of new needs and new challenges and new opportunities for everyone to learn. This is actually, by the way, why I came to work on NSX in the first place. So learn all these new things, learn automation tools, cloud-based networking and security, things I wasn't working on earlier in my data center network architecture roles. So I just think this is an immense opportunity for these teams. So now let's talk about how the product is being used. What are the use cases? And we've been grouping them. We used to group them in these three, and this fourth one at the edge, cloud native apps, has really been growing. So we're adding this fourth one. So these are not mutually exclusive, but they each represent a fundamental core concept for what software, defined approach for what network virtualization based approach enables. From security to multi-cloud networking to automation and to a new approach for cloud native applications. Okay, so let's start with security. So if we take a step back to just the general world, we think about security. I think we all recognize, despite only increased spend within security space, there's also only been increased hacks, increasingly volatile threat landscape, unfortunately. We've seen a lot of public cases, and of course there's a lot of cases that haven't gone public and that companies try to limit the damage of. And if you look into how these are happening, what often happens is there's a vulnerability in application. A malicious actor who either wants to take down an application or wants to, in in most cases actually retrieve sensitive data, will find that vulnerability, get into that application, and once they're through the perimeter of our traditional security approach, which is basically a perimeter firewall, they basically have free reign within the data center from there. This is what we call the lateral spread of threats, and it's hard to stop. So traditionally, we've put a firewall at the perimeter. Said it's kind of like our moat around the castle. If you get over the moat, you're kind of get free reign of the castle. So we're just going to hope you don't get over the moat, and we'll maybe make a bigger moat and hope that you don't buy a boat to go, swim through the moat. But what network virtualization allows us to do is take a different approach, which is bringing that security past the perimeter into a much deeper realm, running at the hypervisor layer, and allows us to bring the security to every single workload, to every VM, to every container. And this is what we call microsegmentation. And this is what NSX kind of really started and has been leading the path and kind of created a whole industry around, to be honest. There have been a lot of advancements in how NSX implements microsegmentation, but it starts with that fundamental concept of bringing a firewall down to every individual workload, not only at the perimeter, so that when somebody can get in, they're still blocked at that workload. And this helps us not only increase security across the board, but it opens up new models for how we manage security and how we think about other security challenges. For example, regulatory compliance. If we take the example of PCI scope, it used to be a PCI compliance required that we built a completely separate physical infrastructure for the PCI zone than the non-PCI traffic to comply that basically retail purchase transactions were not being done on other infrastructure that may somehow get access to those. Now we can use this software-defined separation of these workloads to enforce a PCI scope. And there's actually some white papers on this particular topic, just an example of how auditors saw this approach from a PCI standpoint with approval. But this is just one example. From there, we've actually been enhancing basically how microsegmentation is implemented with NSX, which is that distributed firewall across all of our hosts from data center to cloud, to basically be increasingly application aware, to use the application context, what you may see us call as context-aware microsegmentation. Not only using like VM attributes, which is pretty handy to write our policies for what should not be able to talk to each other, through a central set of policies that we don't have to manage on every single VM, but are rather managed centrally. We're now also extending that to look at application identification through layer 7, DPI techniques, as well as other application variables that vSphere is able to retrieve. Of course, in addition to things like IP address and ports and things like that. But the tricky thing with those is you don't want to be too reliant on them, since a malicious actor can kind of hide behind those and hide behind a particular port or something like that. So this has been transformational in how we think about security. So one example customer who's been evangelist of this at VMworld and other shows is Interfaith Medical Center, Chris Friends, who talks about, in their case, the increasing number of IoT devices and how that creates an increasing need for the network to be segmented and to prevent the lateral spread of threats, especially in such a critical environment that serves patients. So second use case bucket, I'll call it, that I want to talk about is automation. If we think about how network changes our service today, often there's a ticket or maybe an app has been provisioned by a vSphere team and is ready to go live in the production network. Maybe developers finished the app and ready to go live in production network. And even though the VM itself takes minutes to create, what we find is it actually takes on average up to 12 weeks to go live in production. And that's often, because of bottlenecks within the network team, within bottlenecks in the security team, which isn't to point fingers, but actually point out that there's a lot of complexity in networking and security. And the nice thing about network virtualization is when you bring these functions into software, it's even more natural to start to automate these things, whether it's through a blueprint of a commonly repeated task, through cloud management platform like vRealize Automation or OpenStack, or if it's through API calls and automation script that you've built yourself. Our team has done a lot of work to plug in to newer tools, which started with Puppet, Ansible, and Chef for cloud automation some years ago, and more recently this year putting out a Terraform provider as we got more requests for that. But all that whatever the tool is, no problem being able to use an API to create whatever security rules you need, to start whatever distributed switch connectivity you need, routing, load balancing, security policies, etc., all through automation, which has taken production time for our customers from weeks down to days, in some cases hours and minutes. It all depending on basically, it's just about us getting out of our own way at that point. And so one customer who has done this and spoken about it a good deal is Deluxe, and they found that actually, speaking of timelines, their delivery went from 30 to 40 days as the outsourced teams worked to provision new services, down to 48 hours through both network virtualization, automating networking and security, and the vRealize suite, vRealize Automation, etc., automating on top of that, basically programming automation. The third use case bucket I want to talk about is networking and security for cloud native applications, which is really how NSX is being applied per container at a technical level, but also how we integrate, how should that even look? Before we even get into the integration, how should that even look? And so before getting into that, I thought this data was pretty telling and representative of what we've been seeing. There's a number of challenges when it comes to deploying containers and re-architecting applications in microservices-based architectures and getting support from that across IT teams. And it turns out that actually networking and security are two of the top challenges. And this is exactly what we're trying to address with NSX. So with NSX, specifically here, talking about the NSX Data Center platform, we started with supporting this container network interface and plugging NSX and these services directly into the container. But from there, that was just the first step. From there, it came about, okay, well, how are these microservices being developed? Well, they're being developed with orchestration tools like Kubernetes, or application platforms like Pivotal Application Service through Pivotal Cloud Foundry, or enterprise-grade Kubernetes offerings like VMware's PKS or Red Hat OpenShift. And so what we've done in the NSBU within VMware is plug NSX into these platforms so that it's actually not only pulling from the administrative GUI, which it still is, but it's reading. There's kind of a back and forth between how developers are spinning up these containers through their YAML files, which kind of tell Kubernetes and these other platforms what should run in these containers, and using the YAML file metadata to inform how NSX is delivering these services with topologies such as those that I'm sharing right now, which allows NSX to do a really unique thing, which is not only apply this automated networking security to containers, but do it from the same place that it's doing with VMs. So now, even before we think about these networking services, we've kind of done an interesting thing, which is kind of turn the light on in that black box of containers and allow us to look at what is even going on with these microservices. What is the flow from one container to another container? What should it be? And then when something goes wrong, can I go detect whether, which firewall rule may have blocked that, or where did the flow break down within the microservice, and actually work together with my development counterpart to make this app development cycle go faster, to help fix applications faster, and to have a more collaborative, more cyclical conversation when it comes to improvement and redeployment of applications. So really exciting stuff here. We've seen a whole lot of momentum this year with this particular use case. One customer that was just sharing this story with us at VMworld is NCB, National Commercial Bank out of Jamaica. And what they found was a lot of what I was talking about before, that as they move to more agile-based apps in parallel with their traditional app, keeping the light on, they wanted one platform to enable the visibility, the networking, and the security across each of these. And they found that with NSX, specifically NSX Data Center. The fourth use case I want to talk about is, okay, so we talked earlier about this virtual cloud network vision and extending networking and security across data centers, across clouds. So what does that actually look like? And this was actually one of the earlier use cases of network virtualization, which in parts, and not for all these use cases, but for certainly for this use case, uses the mechanism of overlay networks, so tunneling mechanisms, such as through VXLAN tunnels or Geneve-based tunnels, basically saying, why think about a single network domain within a geographic area, within a building? If I've got multiple data center buildings, multiple data center sites across the geographic location, I want to think about my VMs across all of those in a holistic fashion, to write security policies for all of those in a holistic fashion. So this is what we started to call as multi-site NSX, what you'll see architecturally implemented through cross vCenter NSX, and what we now, as we've extended this to not only across private data center sites, but to cloud sites, we generalize more broadly as multi-cloud networking. But it's so when we say multi-cloud networking, it's just that. It's using NSX technology to pull together resources across private data centers, as well as between data centers and clouds, and say, I want to think about this holistically, all of my workloads. I don't care where they're running. My security policies will be managed centrally and will be based on what the application is doing, not where it's sitting. And same goes for how networking, connectivity, routing, VPN management is all orchestrated and administrated. One customer that's made great use of this is Aerodata, who you can find a case study of on our website. And they actually have an active data center. So while many of our customers use this technology across private data centers for more automated networking and security when it comes to disaster recovery, Aerodata does that, but through fully active sites. So all three of their sites are active and actively actually distributing load of incoming requests across 3 unique data center sites. So if one goes down, the other 2 are picking up the requests of the other ones. Really interesting case. So this is that kind of wraps up those 4 big use case buckets for how NSX technology is used, NSX Data Center and NSX Cloud. But this also encapsulates a longer journey for VMware in networking that started with that distributed switch back in the late 2000s, 2008, 2009, to the time when Nicira was acquired to enable virtualization, network virtualization, to the explosive popularity and need for microsegmentation, which kind of evolved into more multiple domain environments with NSXT data center technology, to KVM environments, as well as vSphere environments, as well as public cloud environments. And now just kind of the portfolio evolving even more and more with cloud native applications through PKS, through good behavior first type security with App Defense, into public clouds, hybrid connectivity options through SD-WAN, And all of this coming together through the virtual cloud network. So it's been quite a journey for VMware. We've learned a lot from this experience. We're super excited about bringing this all together for this virtual cloud network vision, which we've started to deliver on today. And you'll see lots of exciting things coming from us, I'm sure, with the great team we have here over the next months and years to come. Of course, we're doing this in tandem with our ever important partner ecosystem, where whatever tools you like to use for operations, for security, can be plugged into this platform in parallel. And we've seen massive traction with this. Our CEO, Pat Gelsinger, talked about having now reporting over 7,500 NSX customers across the board. We're also really particularly proud with the recent momentum we've had in our certifications and VMUG activity. So go check out our VMUG forum, discussion boards where all sorts of great conversations are happening about how things are configured, how different architectural approaches are being considered, and as well as folks who have gotten their certification who are helping out their peers, which we love to see. Better hear it from your peers who are doing it themselves, in addition to getting the direct support from VMware. And on that, we are absolutely, of course, here to support you. There's all sorts of resources, a growing pool of resources, from what I just talked about to our hands-on labs where you can go play with NSX Data Center technology yourself for free in a hosted environment hosted by VMware. Go check out the hands-on labs page. Lots more resources, blogs. Catch up with us on Twitter. Our product, the rest of the product team here, product management, product marketing, are all pretty active on Twitter, and happy to hear about your story, happy to get feedback, pull you into a customer feedback session if you have some constructive things to say. It's really important to us. So with that, I'll conclude this talk, and I thank you for your attention and for your interest in this session. And we will now shift to questions and answers. You can use the Q&A box to ask those. Thank you very much.